Okay, Bismillah ar-Rahman ar-Rahim. This is the last video for the year, just simple revision of what we've taken with more emphasis on the second part. The second part is the material covered after the first or the midterm. So the way I'm going to do this revision is I have the book here beside me, and what I'm going to do, I'm going to go over every chapter and just remind you of the main ideas and what you should be at least aware of, and what you should learn, and what you should not expect, but you're expected to know very well. That's what you should at least look forward in this video or series of videos. So what I'm going to do first is I'm going to tell you I'll remind you with what I said in class, is that the material is actually covered, or the test, the final will be simply split into 75% and 25%. 25% from the midterm or the final will be comprehensive. Comprehensive, that means it will include everything from the beginning till the end. And 75% of the test will be mainly on chapters 25 onwards. So chapter 25, 26, 27, 28, and the first bit of 29. So anyway, so let me just quickly remind you of some of the main things that you expected to know from the first part of the course, and starting with Coulomb's force. So if between two charges, which we said K Q1 Q2 divided by R12 square R hat, that's the force between two charges. And if you remember, we've done this quite a bit, and from here we actually got the electric field, which is the more important one, and the electric field was simply F divided by Q, and Q naught. Q naught is, we said that it's a test charge that is positive, and it is very small. So we did that. So that's the first thing that we started with, and after that we went into calculating the electric field. And we calculated the electric field in two ways. For a group of charges, the electric field at some point was equal to K Q divided by R square R hat. Okay, and Q is just if you have a charge somewhere here, or a group of charges, and you want to calculate the electric field at some point P, then this is the formula used. So this is for a point charge. And then if you have a continuous charge distribution, so if you have a continuous charge distribution, then the electric field was equal to dq over r squared r hat, and then you have 1 over 4 pi epsilon e. Now we've taken this, but there will be no questions on that in the final. So we will not talk about that in the final, or will not ask questions on how to calculate the electric field. You will be expected to calculate the electric field due to a point charge or a group of point charges. If you have 2 or 3 charges, Q2, Q3, then you wanted to do that, calculate that, and then the sum will be the sum of E will be Q1 plus K Q2 R2 squared R hat plus K Q3 divided by R3 square R hat. Okay, so you're expected to know that. So that's the first part, or the first thing that we have done, and you should know at least there's something here you do not have to do. After that, we went into the potential V. So we calculated, after that we've calculated the potential V, which was simply was 1 over 4 pi epsilon naught Q over R, not R squared, Q over R. And this is due to the potential due to a point, and the potential due to more than one point simply plus Q Q1 R1 Q2 R2 plus so forth. That's if you have a group of charges and you wanted to calculate the potential at some point. Now the one thing you should be aware of here since V is proportional to 1 over R, then you expect V to go to be 0 at R when R goes to infinity. So the potential is equal to 0 at R infinity, and this is where we calculated, if you remember, we calculated the electrostatic potential energy. So the electrostatic potential energy, which was simply Q multiplied by V, V being this guy, the potential. And if you have a group of charges, you have to be careful. I should go over this one more time, calculating U. Calculating V is easy, so you just need the distance from the point P to each charge, and Q1 over R1, Q2 over R2, and so forth. But the potential energy is the electrostatic potential energy is the one that we have to be careful with, or you have to be aware of how to calculate that. And I know there are some people make mistakes when they calculate that. So suppose that I have, I'm just going to 3 charges, Q1, Q2, and Q3. Okay, 3, and I wanted to calculate the electrostatic potential energy. Let's say at Q1. If I'm doing it at Q1, it will be simply U at 1 will be simply, of course, you have K, and then Q1, Q2 divided by the distance plus Q1, Q3 divided by the distance. This distance, let's call it R2, and let's call this distance R3. That's if you're calculating the potential energy at point Q1, okay, or at the point where the charge Q1 is located. Now, if I'm calculating the potential energy for the system, which is called total potential energy, so U total, then it will be a little bit different. And just you have to do all the possibilities. So Q1, Q2 divided by R1, Q1, Q3 divided by the distance between them, 1, 3, 1, 2, plus Q1, Q2, and the distance between them. So then you have to use, or see the difference between the two. In here, you calculate only the, if you're calculating the potential energy at the point where Q1 is located, then you just multiply these two. Only you have 2 terms. Remember, this is multiplied both, right? But if you're calculating the total potential energy, then the things are a little bit different, where you have to calculate all the possibilities you have. Okay, so that's the potential energy. So we covered the electrostatic field, the potential energy, and the 4-point charges. Now I'm talking about 4-point charges. The other thing that you should be aware of, you may not need to calculate that or show that, but you have to be aware of, is calculating the electric field using Gauss's law. If you recall, Gauss's law says that phi net is equal to E dotted with dA